Crack-a-lackin' peeps, it's Professor Sugarfoot on pills and/or automobiles. Today's show is about the evolution of antibiotic resistance. Guest host is my main man. There's a chance I don't have any idea what I'm talking about. And yes, people, that is his name.
No.
Sugarfoot checking back in. Anybody have any questions?
What is antibiotic resistance?
It is a consequence of evolution via natural selection. The antibiotic action is an environmental pressure. Those bacteria which have a mutation and allow them to survive will live on to reproduce. They will then pass this trait on to their offspring, which will be a fully resistant generation.
What can that lead to?
A bunch of goddamn medicine that don't work. Now I'm chiming in from a cave in North Korea. My co-host. There's a chance I don't have any idea what I'm talking about. I'll give you further insight on this topic.
40 or 50 years ago, thanks to antibiotics, scientists had thought medicine had all but eradicated infectious diseases. Instead, the past 2 decades have seen an alarming resurgence of infectious diseases and the appearance of new ones. According to PBS, the AIDS virus, tuberculosis, malaria, and diarrheal diseases and other infectious agents pose far greater hazards to human existence than any other creatures in the world.
So there's a chance. What factors into the spread of diseases and the decrease in potency in these medications?
Well, for one, Sugarfoot, the rise of relatively cheap international travel allows diseases to travel from continent to continent without any barriers. Another factor that comes into play is inadequate sanitation and the lack of clean drinking water in countries where diseases run rampant. Lastly, an overuse factor comes into play with antibiotics, where they come to a point where they lose their potency or miracle abilities.
To further elaborate on what he just touched on, we have a video to show.
The non-resistant bacteria are killed off, which happens especially quickly in antibiotic-rich environments like hospitals. There is more room and resources for the resistant ones to thrive, passing along only the mutated genes that helped them do so. Reproduction isn't the only way to do this. Some can release their DNA upon death to be picked up by other bacteria, while others use a method called conjugation, connecting through pili to share their genes. Over time, the resistant genes proliferate, creating entire strains of resistant superbacteria. So how much time do we have before these superbugs take over? Well, in some bacteria, it's already happened. For instance, some strands of Staphylococcus aureus, which causes everything from skin infections to pneumonia and sepsis, have developed into MRSA, becoming resistant to beta-lactam antibiotics like penicillin, methicillin, and oxacillin. Thanks to a gene that replaces the protein beta-lactams normally target and bind to, MRSA can keep making its cell walls unimpeded.
Damn, that's just scary. What can drug companies and the average person alike do to slow this process down?
While pharmaceutical companies strive to develop new antibiotics that kill these drug-resistant microbes, much can be done. That means not asking for penicillin or other antibiotics when all you have is a cold, since colds are caused by viruses that are not affected by any antibiotics. It means taking all the pills that are prescribed, even if you're feeling better. Physicians have to resist prescribing the strongest and most broadly effective drugs unless the disease absolutely requires it. If society adopts these measures rigorously, the drugs may soon regain their miracle powers.
Well, thanks, there's a chance that I have no idea what I'm talking about. You've been a great co-host and you've been very informative. Thanks for tuning in to this episode of Pills and Automobiles. It's 10 o'clock and I'm hungry. Peace, I'm out of here.